So in today's class, we are going to discuss about temperature, that how will temperature affect the change, affect the position of the equilibrium. So basically, equilibrium, if you recall, we understood that there is a ratio of the reactants and products. So the temperature at which that equilibrium is established, that temperature is aligned with those amounts. So for example, if I increase the temperature, so what happens? There is an increase in temperature. So according to the Leach-Atelier principle, that increase must be minimized. Is this understandable to all of you? Yes.
Yes.
Okay, just give me a minute, please. So according to the Leach-Atelier, we have to minimize equilibrium shifts in a direction which minimizes the change. So here, for example, if the equilibrium was established at 25 degrees Celsius, and then we raise the temperature till, let's suppose, 80 degrees Celsius, it means that the change is increased temperature. So we have to minimize this increase in temperature. Is this understandable to all of you?
Yes, sir.
Okay,
Yes,
so
sir.
to minimize the increase in temperature, we have to remove that excess energy which is leading to that increase in temperature. So how could we do this, or how could this change is minimized? By absorbing the energy. So can anyone recall which reaction, what, in which reaction the energy is absorbed? Yes. Isn't it endothermic reaction? So it means that increase in temperature shifts equilibrium towards endothermic side. Is this clear?
Yes, sir.
So it means that the reaction will be there until the inner endothermic side, the reaction would shift until the equilibrium restores again. So we have to figure out whether the reaction, the forward reaction is endothermic or the backward reaction is endothermic. Okay, it means that when we decrease the temperature, equilibrium shifts towards the exothermic decrease in temperature. So let me write this over here as well, that decrease
Assalamualaikum, sir.
walaikum assalam, in temperature walaikum assalam shifts equilibrium towards exothermic side, because when we lowers the temperature, the change is decrease in temperature. So we have to minimize this change. It means we need more energy. So equilibrium shifts in a direction which is exothermic, and as a result, energy would release until the equilibrium restore again. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so now what conclusions we can make? If we increase the temperature and equilibrium shifts to right, which means towards product side, will make more product. So it clearly indicates that uh, forward reaction is endothermic. And if we decrease the temperature and equilibrium shifts to left, so it means the backward reaction would take place. So it also indicates that backward reaction is exo or endo? Yes,
That's true.
exo. The backward reaction is exo. Very good. If we increase the temperature and equilibrium shifts to left, so what would be the backward reaction in this case?
Endothermic.
Endothermic. So if the backward reaction is endothermic, then the forward reaction must be exothermic. Is this clear?
Yes, sir.
If we increase the
Yes,
temperature
sir.
and, sorry, if we lowers the temperature and equilibrium shifts to right, it means forward reaction is exo or endo?
Exo?
Yes, good. Forward reaction is exothermic. Yes, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. If any one of you has any confusion in this, please ask. Yes. Okay, then. Now, we will be starting the new subtopic. Equilibrium. Expression. These equilibrium expressions are also called equilibrium constant expressions, and these are of two types. First, why they are, what are these basically? So these are used to express the ratio of the products and reactants at given temperature at equilibrium. So basically, these equilibrium expressions are the ratios of the reactants and products, and C at given equilibrium. So we are saying constant, so they are temperature specific constant. It means if temperature would change, their values would change. Otherwise, if we change any other thing, their value would not change. Is this clear?
Yes, sir.
Yes, sir.
So there are two equilibrium constant expressions.
Sir, could you please explain it again?
What about temperature thing?
Yeah, the thing you said, the temperature is like the only factor that will affect this.
Actually, I just uh, we will discuss it later on as well. But the thing is that this we are calling them constant, right? So these are temperature specific constant. These values stays constant at a specific temperature. For example, if we are changing the concentration, if we are changing the pressure, and due to which the equilibrium position is shifting, but the ratio of the reactants and product would not change, it stays the same. This value will stay the constant. But if we change the temperature, then due to the change in temperature, the Kc value would, the equilibrium constant value would affect. It will not stay the same, it will change if the temperature is changed. Is this clear?
Yes, sir.
Okay. Now, equilibrium constant Kp. Okay. So first we are going to discuss equilibrium constant Kc. So here the C, which is written in the subscript, basically, it refers to the concentrations of reactants and products at equilibrium. So it means we will discuss the concentrations at equilibrium only, okay? Another important thing over here, to represent
Sir, concentrations of what? Like the reactants and
And
products?
products both, yeah, reactants and products. So to represent the concentrations of reactants and products, we for Kc expression, their formula or symbol is enclosed in square brackets. That is very important. If you don't enclose it in a square bracket, you will lose marks. For example, if I write HCl in this square bracket, so it means that it's not hydrochloric acid. It means I am saying it's the concentration of hydrochloric acid. In the same way, for example, if I write NaOH, sodium hydroxide in a square bracket, or let's say if I write hydrogen in a square bracket, it means it's the concentration of that substance. Is this clear to all of you?
But sir,
Hmm.
how is it the concentration? Like there are no numbers.
There are no, yeah, I am representing the concentration like this, but after that, when we will going to solve any numerical problem, we are going to use the numbers. But before that, when we are making that Kc expression, we will not write it like this. For example, concentration. For example, instead of writing that concentration for a formula or for the expression concentration of HCl, no, we can't do this. Instead of this, we will just write it like this. It means concentration of hydrochloric acid. This thing represents it's a concentration of hydrochloric acid. Whatever the value I am going to substitute over here, it's the concentration. And as it's a Kc expression, it's a equilibrium constant expression. So I'm going to put the concentration of hydrochloric acid, which is at the equilibrium. Is this clear now?
Yes, sir.
Okay. Yes, Ashal, Ahmad,
Yes, sir.
and Yusuf, is this clear?
Yes, sir. Yes.
Yes, sir.
Kubra, is this clear to you as well?
Yes, sir.
Okay. Now, let's have a look at a chemical equation. I'm not writing any specific chemical equation. Instead, I'm using a general chemical equation in which A is a some reactant and B is another reactant. And they are forming C one product and D another product. And there is a equilibrium because there is a reversible arrow, which means that this reaction does not goes to completion. Instead, it will establish a equilibrium. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Now, normally we balance the equation as well. So these M, N, small p, small q, all are the number of moles which are used to balance a chemical equation. Is this clear to all of you?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
over here, this A and B are reactants. This C and this D are products. And this M this N, this P, and this Q, all are number of moles in a balanced equation. Is this clear?
Yes, sir.
Okay.
Yes, sir.
If I have to write the Kc expression, then see how we will write. So I will write Kc is equals to our one of the product is C and the other product is D, right? So in a square bracket I will write C, and then in the other square bracket I will write D, which means that the concentration of C times concentration of D. And then in the denominator, I will write the concentration of A times concentration of B. Is this clear?
Yes, sir.
Yes, sir.
Now, next thing. C, what is the number of moles of C in the chemical equation? Are they small p? So the number of moles that are present in the balanced equation will be the powers in this Kc expression to the concentration of that specific reactant or product. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now, we are going to look at few examples. Example number 1 has hydrogen reacting with iodine and a reversible reaction forming HI. If I'll balance this equation, I will put a 2 over here. Now the equation is balanced, right? So if I have to write its Kc expression, the Kc expression would be, who left the class? Kubra. Now how many reactants we have? Yes. There is a one reactant, hydrogen iodide HI. So I will write it in the numerator in a square bracket, and there are 2 moles of that hydrogen iodide. So I'm going to put a 2 as its power. So the square of the concentration of hydrogen iodide divided by concentration of hydrogen raised to the power 1, because there are 1 mole of hydrogen in the balanced equation times concentration of iodine raised to the power 1, and we don't use right 1, right? So that is how we will write the Kc expression, and examiner specifically ask you to write the Kc expression for 1 mark. Is this clear to all of you?
Yes, sir.
Now, if I'll move for unit, then what does this square bracket means? Yes? Can anyone recall what does this square bracket means? Yes? Yes, Hamza, can you tell me what this square bracket represents? What does this square bracket means? Yes, Hamza. Yes. Yusuf?
Sir, equilibrium constant.
No. Kc is equilibrium constant. This square bracket means it's a
Concentration.
concentration.
Concentration. Yep.
So, hydrogen iodide. And what is the unit of concentration, Hamza? Yes, Hamza. What is the unit of concentration? Yes, Ashel. What is the unit of concentration? Yes, Yusuf. What is the unit of concentration?
Sir, mole per.
It's mole per dm cube.
Yeah.
So, in denominator, in numerator, I will put mole per dm cube, and there is a square, right? So I will put a square, and in numerator there is a mole per dm cube whole square, and in denominator there are two concentrations, so which means mole per dm cube times mole per dm cube, isn't it?
Yes, sir.
Okay. So in this case, aren't they all get cancelled?
Yes, sir.
So in this case, there will be no unit, but it is not for every chemical equation. For every chemical equation, there will always be a different unit for Kc expression. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now I'm writing few equations over here, and I want you guys to calculate their Kc expression, write Kc expression, and then unit, and then WhatsApp me your answers. Okay. Okay, now who is going to tell me how to balance this equation? Yes, can anyone tell me how to balance this equation first before start writing the Kc expression? And here we will get sulfur trioxide gas. And then how to balance the second equation? Yes, first equation, how we will balance it? Ahmad, can you tell me?
So we would put a 2 with on the right side,
On the right side, we will add 2. Okay.
and on with SO2 we would write 2 as well.
No, first is the first equation is balanced.
Oh, sir, I was balancing the C. Okay, oh, sorry, sorry.
Sir, 3 with H2.
Very good. And put a 3 with H2. Now the first equation is balanced. Yes, Ashal, can you tell me how to balance the second equation on the screen? Okay, now everyone start write the KC expression for all of these equations and then unit for them. And I don't just need the answers, I need this workings as well. WhatsApp me, but before balance the second equation, third equation, if you guys see, it's already balanced. Yes, Ashal, how to balance the second equation? Ashal,
Sir, we will put a 2 with SO3 on the right side
okay.
and then put a 2 with O2, I think. Yes.
Now there is one cell. If you do this, then how, see, there are 2 sulfurs over here and over here there is a 1 sulfur, so it's wrong balancing. So we will put a 2 over here. Now see, 2 sulfur, 2 sulfur. How many oxygens? 2 times 3, 6. Here we got 2
Yes.
oxygens, here we got 4 oxygens, so 4 plus 2 is 6. Now it's correctly balanced.
Okay, sir. Okay.
Okay, now write the KC expression for all of these and units and then WhatsApp me.
Sir, we have to add units separately, right?
Yeah, the way as I did like this.
Okay.
I want this whole thing balanced equation, then KC expression, then units working, and then after working whatever unit you will get over here. All these in one picture that you will going to WhatsApp me. Do this quickly, everyone. I have received from Cobra. Okay. Okay, you have to open the bracket, then apply the square, whatever the power will be, otherwise it's correct. Okay, Kubra, your working was fine. Yes, Ashel, Yusuf, and Hamza, I'm waiting for your responses. Okay, I have received from. Okay, I have received from Yusuf as well.
Sir, I'm confused in the last part.
Okay, if you made the equation, send it me. Why you left the charges? Your second one is correct, Ashel. Your first one is correct. In third, there is a mistake. Kubra, you didn't send me the third one.
Sir, is the mistake in KC or unit or in both?
In both.
Okay, sir.
Okay. Your third one is also wrong, Yusuf. The first and the second one is correct. In the first one, there is an issue in the unit. Okay. Your both are fine. In third, you didn't do. Okay, now let's have a look. If we will go for KC, for first one, it is going to be. And remember, if you instead of making square bracket, you make a round bracket, then you will be marked wrong. So you have to restrict yourself to square bracket only. So square of ammonia concentration divided by concentration of nitrogen times concentration of hydrogen cube. Is this clear to all of you? Then in this case, Kc is equals to concentration of sulfur trioxide square divided by concentration of sulfur dioxide square times concentration of oxygen square. Is this clear? Now in this case,
Yes, sir.
okay, tell me about concentration. Concentration is for which type of substance? Liquid, solid, solution, gas, what it is? Isn't it solution? The concentration is for solutions, isn't it?
Yes, sir.
So if you look over here, it's a solid, right? So solid doesn't have any concentration. So if I will write the Kc expression in the numerator, I will just keep iron 3 positive ions raised to the power 1 divided by concentration of iron 2 positive ions times concentration of silver ions. So that is how we will write these Kc expressions. Yes, is this clear to all of you?
Sir, why don't we have silver in numerator?
Because this silver, look at the state. What is its state?
It's in solid. Okay.
Solid. And these are concentrations. And concentration, if you recall, we define concentration is the number of moles of solute dissolved in a decimeter cube of a solution, isn't it?
Yes, sir.
So it's not dissolved, so it's not the part of the solution.
Okay, sir. Got it.
Okay. Now, let's move to the units. So here, in numerator, we will have mole per dm cube square over mole per dm cube times mole per dm cube whole cube. So this whole square cancel out with this cube and we are left with 2 mole per dm cubes in the denominator. So if I solve them, they will become mole per dm cube, and if I move them to the numerator, they will become inverse square, isn't it? And when we apply the square, when we open the bracket and apply the inverse square, it will become mole inverse minus 2 and dm raised to the power 6, not 9, Yusuf. Is this clear?
Sir, if we won't do this last part, it would be correct, right?
But it's always appreciated if you will write in this way, not in this way. Okay, that will be considered as incomplete.
Okay, sir.
Okay, so here again we have mole per dm cube whole square in numerator, mole per dm cube whole square in the denominator, and mole per dm cube. So these two would cancelled out and we will left with 1 upon mole per dm cube. So if I move it to the numerator, it will become mole inverse dm cube. Is this clear?
Yes, sir.
Now, if I'll work for the units for this one, I have mole per dm cube. Then I have mole per dm cube times mole per dm cube. So these two would cancelled out, and again we will left with 1 mole per dm cube in the new denominator. When it will move to the numerator, it will become mole inverse dm cube. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, Ahmad. Yes, Ahmad, Yusuf, and Kubra, is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So today's class we will keep it till here, and in the next class, do review these and the factors which can shift the equilibrium position before the next class, which will be on Friday at 3. And we are going to discuss some past papers related to these KC expressions and those factors. Okay.
Okay, sir.
Okay, sir.
Okay. Take care, everyone.
Thank you, sir. Allah Hafiz.
Hafiz.